This video is to help you with designing your tank for the project as well as the pump. The first thing I'm going to do is just draw a real rough schematic of the landscape. So here's our hill that basically goes from the water down here. This is at 0 feet of elevation, and you're going to mark on here where is your lowest house and your highest house in the network. So lowest one somewhere down here, let's say it's at 13 feet, and your highest house up here is going to be, let's say, at 61 feet. You might interpolate a little bit differently than me. That's fine. This is just an estimate. So here's my house. Here's my house. We know that we need to be between 40 and 70 psi everywhere in our system. So ask yourself, where in my system is the pressure going to be the lowest? And where is the pressure going to be the highest? Think about that for a minute. We've got a water tower somewhere that's controlling the pressure in our system. Where are we going to have the lowest pressure? We're going to have the lowest pressure at the highest point, and we're going to have the highest pressure at the lowest point. So down here, we want to be sure that this house has less than 70 psi, and up here, we want to make sure this house has greater than 40 psi. If we have this top house have greater than 40 psi, the bottom one will, and if the bottom one have less than 70 psi, the top one will as well. Okay, so now we want to say, where do we need to set our tank level? If this top house is at 61 feet, and we need to provide 40 psi on top of that, one way of figuring out what the head in the tower would have to be to provide that is to convert the psi to feet of pressure head. How do we do that? Multiply by 2.31. 40 psi times 2.31 is 92.4. So from our 0 datum, this house 61 feet high, and then on top of that we need another 92.4. If our tower is at least 92.4 plus 61 feet, if the level in it, or the elevation, is at least that high, we should get 40 psi in our house. I'll correct that a little bit in a minute, but for now, that's good. This lower house is 13 feet of elevation. 70 psi converted to pressure head is 161.7. So from here, we go up 161.7. If I add to that 161.7 the 13 that I started at, I get 174. Sorry, my pen is giving me issues here. 174.7. And then over here, if we add the 92.4 to the 61, we get 153.4. So what this is saying is that my water tower has to have a water level greater than 153.4 and less than 174.7 to be within this pressure range. Now, there's a little bit more to it because there's head losses between the tower and these houses. So you have to figure out, you're going to let the model figure out what those head losses are, but this should at least give you a band within which to design your water tower. Depending on where you place it, it's going to be a different height, but the water level in the tank still needs to fall in that elevation band. Now, let's just say, for example, we're going to kind of draw a little line here. Let's just say we pick a tank, and let's say the water level, actually, I'm going to undo that. let's say the top water level right here, the max water level we put is 170 feet. I'm not saying that's what you should do, but let's say that is what we did. One of the constraints in your system is that the pump has to be able to fill the tank. Remember that this is on some slope, there's eventually some zero, and your pump is located down here at 0. If I draw the axes here of my pump and system curve, we have 0 down here, we have the tank up here at 170. In order for the pump to be able to fill the tank, the pump curve has to at least be as high as 170 feet. So if my pump curve looked like this, the highest head it can provide is right here. It's not going to be high enough to fill the tank. Okay, so that requirement that the pump be able to fill the tank is going to affect the pump shutoff head. Remember that the system curve for this system is pumping from the lake to the top of the reservoir. That means the static head that has to be overcome is from the reservoir up to the level in the tank, plus it has to overcome any head losses. Okay, so when you're designing your pump curve, keep in mind what is your water level in your tank and make sure that your pump can fill that tank. As far as what kind of flow your pump has to provide, remember you're going to be locating a point on this pump curve just with one point. It's going to be a Q and an H, and you have to pick those two. What value you put in there for the H is going to affect directly the shutoff head. Remember that what EPANET picks for this intersection point is equal to 1.33 times, we'll call this H star and Q star, H star. And what it picks for where this intersection is of the pump curve down on the Q axis is going to be 2 times Q star. Whatever you put in for this point, it's going to multiply it by 2 to get to that point. What does that point have to be? Well, I'm going to leave that up to you to figure out. It's a little bit less constrained than the shutoff head of the pump, but it is constrained at least somewhat. There is some bounds on it that make sense, and both on the lower and the upper side. So I'll leave that up for you to design, but at least this should give you a start for figuring out what levels should my tank be, and what kind of a pump curve am I approximately looking for. I do recommend designing where your tank is and what its levels are going to be before you start designing your pump. All right, so with that, you should be able to get to the point really where you can basically finish the project. You will probably run into some questions and issues at some point, but this should give you a really good start. Start putting some things in, trying some stuff. And again, you just want to make sure that you are not like starting on the FireFlow simulations the weekend before it's due. Make sure you're starting on those maybe a week before it's due. If you're able to do that, you probably will have enough time to write everything up. That's just my recommendation based on my experience. If you can get them done even earlier, that's great.